Hi, this is an audio reading of Extending Your Knowledge reading selection from the Weather and Climate Systems Unit, the source of Earth's heat. After school, the air is warm, moist, and breezy. Fat raindrops hit the pavement. Lightning flashes and thunder rumbles in the distance. In the west, the sky is dark. A thunderstorm is headed your way. What causes the weather and its storms? These are some effects of energy from the sun. Solar energy and heat transfer. Solar energy is the source of most of Earth's heat on land, in the oceans, and in the atmosphere. Solar energy radiates through the vacuum of space to Earth in the form of electromagnetic waves. Some of the solar radiation is visible to the human eye, and some of the radiation, such as ultraviolet and infrared, is invisible to humans. The interaction between solar energy and air, soil, and water on Earth cause wind, rain, and other elements of weather. So take a look down here at this drawing. I'm labeling the sun. And the sun releases solar energy, and that's what's depicted here in yellow. This is the solar energy. Some solar energy is reflected by the gases and clouds. Doesn't even make it to Earth. Some of the solar energy, however, goes to Earth's surface and gets absorbed. The energy goes into those surfaces, and the surface's temperatures go up. The surfaces that we're talking about are going to be ice, snow, soil, forest, water, plus many more. And these surfaces absorb the solar energy differently, which creates our weather on Earth. Sounds simple, right? Wrong. Only a tiny fraction of the sun's energy strikes Earth. Of the small amount that does reach Earth, about half is absorbed by the planet's surface. The rest is reflected back into space or absorbed by the thin blanket of air, the atmosphere, that surrounds the Earth. So let's head back to our picture. We talked about solar energy going into Earth, and that's called being absorbed. Some of the energy doesn't get absorbed, though. It just gets reflected off. Snow and ice do a really great job at reflecting sunlight. Therefore, they don't absorb the light. Earth has various kinds of surfaces that respond to sun's energy in different ways. Materials such as soil, rock, and water absorb and give off energy at different rates. Look at the illustration. A snow-covered surface absorbs only 10% of the solar energy it receives, while a dark area such as a dense deciduous forest absorbs much of the solar energy it receives. The temperature of a surface such as snow or forest is an indication of the amount of sun's heat energy that has been absorbed. Differences in how Earth's surfaces absorb sunlight and give off heat energy relate to wind and weather patterns. Because the planet is unevenly heated, air rises, expands, cools, and sinks at different rates in different places. So what this is saying is that you have dark surfaces and you have light surfaces. The dark surfaces are going to absorb more energy, and the light surfaces will absorb less. The light surfaces tend to reflect more light, and the dark surfaces tend to absorb more of that energy. And when I talk about dark colored surfaces, I'm talking about the soils and the forests. And when I'm talking about light colored surfaces, I'm talking about the snow and the ice. All of the heat reflected from Earth's surfaces would travel back into space without any difficulty and leave the planet cold if it were not for Earth's atmosphere. Certain gases in Earth's atmosphere absorb some of the heat energy, trapping it in the atmosphere and then sending it back toward the surface again. So, to recap, the sun releases solar energy. This solar energy is absorbed by Earth's surfaces and reflected by some of those surfaces. The energy that is reflected back is actually trapped by the atmosphere. This is what keeps our Earth warm, just like a blanket keeps you warm at night. If we didn't have our atmosphere, we would be way colder and wouldn't be able to survive on Earth.